There are two special triangles that allow you to work out sine, cos and tan of 30 degrees, 60 degrees, 45 degrees. So let's just talk about how we get those two triangles. Let's look at the first one. If we had an equilateral triangle, so all sides are the same, and we made each of those sides equal to 2. Now you know that because those angles inside add up to 180 and they're all the same size, that they're all going to be 60. So we've got a 60 degrees, 60 degrees, 60 degrees. If now we drop what's called a perpendicular to the base, so perpendicular means right angles. Now the geometric properties of perpendiculars, particularly with isosceles, is that it bisects the angle up there and it bisects the base. So if it bisects the angle and that whole angle is 60, then that must be 30 degrees. And if it bisects the base, that is 1 and that is 1. So what we're going to do now is we're going to throw away the right-hand side. So we've started with an equilateral triangle of side 2, chopped it in half. That gives us 60, 30. We've still got a 2 there. Now we've got a 1 there. So we'll throw away all this, and we're just left with that. Using our friend Pythagoras, if we call that x, we've got 2 squared equals 1 squared plus x squared, so we can calculate x here. 2 squared's 4 equals 1 plus x squared. Take 1 from both sides. 1 minus 1 is 0. Will just get us to x squared. 4 minus 1 is 3. Take the square root of both sides. Square root of 3, square root of x squared is x. So x is equal to root 3. Okay, so that's one triangle that you need to be able to redraw and redimension. 1, 2, root 3, 60 degrees, 30 degrees, right angle. Now, corresponding to that is what happens if those angles were in radian mode. The sides are still the same, 1, 2, root 3. And we know that if 180 is the same as pi, then this is 1/3, so 60 degrees is 1/3 of that, so it'll be pi on 3. So where this 60 is, I can put pi on 3. And 30 degrees as a fraction of 180 is 1/6, so that'll be pi on 6. So that allows us to be able to work out the exact value of sine, cos and tan of those angles. Now, I will leave calculating those sine, cos and tans of 30 and 60 or pi on 3 and pi on 6 till a little bit later, because I'll just look at the second triangle. The second triangle is simply an isosceles triangle. It's right angular. So we've got 1 and 1. And if we call that C, using Pythagoras, we've got C squared equals 1 squared plus 1 squared. That's 1 plus 1, which is equal to 2, is C squared. Square root of both sides, C is equal to root 2. So we got 1, 1, root 2. Now, if that's a right angle and these are both equal to 1, this is an isosceles triangle, means these two angles are the same. Two angles the same, and they must add up to 90, because if that's 90, these two must add up to 90, because the three of them add up to 180. So if they're the same and they add up to 90, they must both be 45 degrees each. So there's the second triangle we need to memorize. 1, 1, root 2, 45, 45. How does that correspond in radians. Once again, right angle, 1 root 2. 45 degrees. Let's go back up to our conversions up here. So we've got 60 as pi on 3, 30 as pi on 6. We want to know what 45 degrees, what fraction is 45 of 180. 45 is a quarter of 180. You multiply 45 times 4, you get 180. So it's a quarter of 180, so it'll be pi over 4. So this is pi on 4, pi on 4. So these are the two triangles. So if you're in degree mode, you need to be able to memorize those two triangles. If we're in radian mode, and you're talking about radians, you need to be able to also reproduce the two triangles in radians. So where is that leading us? Okay, it allows us to work out sine, cos and tan of all these angles. So I'll just leave that there. And we'll draw up a little bit of a table here. So we've got sine, cos, tan. Let's call it theta. And we've got theta. Now we can either be in degrees or radians. So let's do it in order. So the smallest angle was 30, and 30 degrees is exactly the same as pi on 6. 60 degrees, no, let's go in order, didn't we? So let's erase that and we'll put pi on 45 in there. Now 45 degrees is pi on 4. Now we can go 60 degrees. 60 degrees is pi on 3. Okay, so they are the same size angle, just using a different way of measuring them. If we want the sine of 30 degrees, we go up to this triangle, you've memorized that. Sine of 30, there's my 30. Let's just use another color up here. Oh, okay, we're going to use red. So we've got sine of 30, so we want the sine of that angle up there. Sine is opposite over hypotenuse. That's the opposite, and that's the hypotenuse. So the sine of 30 will be equal to 1/2. Going back up to this triangle again, we want the cos of 30 is adjacent. There's my adjacent. There's the hypotenuse, so it'll be root 3 on 2. And the tan of 30 is opposite over adjacent, so that's 1 over root 3. So they are the exact values of sine, cos and tan of 30 degrees. It's also the sine, cos and tan of pi on 6. Pi on 6 is exactly the same, going back up to this triangle up here in the purple. 30 degrees we've said is the same as pi on 6. It's the same lengths on the side, so sine of pi on 6 will be equal to 1/2. Now 45 degrees, we're going to use this triangle here. But instead of using that one, let's just go this one. So that's pi on 4. Does it matter which pi on 4? No, it doesn't matter which pi on 4 we use. So let's just use this one down here. And we've got sine of pi on 4. Sine is opposite over hypotenuse, 1 over root 2. Cos is adjacent over hypotenuse, also 1 over root 2. And the tan of pi on 4, tan is opposite over adjacent, so that's 1 over 1, which is equal to 1. And now we're on a roll with radians. Let's do pi on 3, which is this angle up here in this purple triangles here, pi on 3. So we want the sine is opposite over hypotenuse, so that's root 3 on 2. Cos is 1 on 2. And the tan is root 3 on 1, or root 3, which is the same as root 3 on 1. So there we go. There's a table of values. Do you need to memorize them? No. Do you need to memorize the triangles? Yes. So memorize the triangles either in radian mode or degree mode, either one of those, and memorize both of them, both degrees and radians, and then just knowing your rules for what sine, cos and tan are, what those ratios are, you can actually fill that whole table in. So you don't have to memorize this, but you need to be able to get to there. Okay.